CBR method. Okay. So in this method, we use the Nigerian CBR approach to design our flexible pavement. So we'll be taking a sample problem. So the question says a 4-lane trunk A highway with a 20-year design period is to be constructed between Aba and Port Harcourt. The expected average daily traffic during the first year is 4,000 vehicles per lane, with 8% of the vehicles exceeding 3 tons loaded weight. The traffic growth rate is 6% per year. The CBR test carried along the proposed highway gave the following CBR. For a CBR of 6%, it was located in 4 locations, 8% for 3 locations, 9% for 3 locations, 10% for 3 locations, 11% for 2 locations, 12% for 3 locations, and 14% for 2 locations. Design the pavement using cement stabilized laterite base of 80% CBR and a sandy clay subbase of 30% CBR. As we know, our CBR is California bearing ratio. Okay. So the first thing we do whenever we are doing such problems is to get our given data. So from the problem, we have the number of lanes to be 4. We have our design period to be 20 years, which is the period we are designing the pavement to last. We have our average daily traffic to be 4,000 per lane. I see there. We have the percentage of vehicles exceeding 3 tons loaded weight is what? 8%. So of the given traffic, the percentage that is exceeding 3 tons loaded weight is 8%. And then we have a growth rate of 6%. For our base cost, we have the CBR to be what? 80%. We have our sub-base CBR to be what? 30%. So in order for us to design our pavement, we need to get the CBR value for our sub-base, our subgrade, which is our natural earth. So the first thing to do is to determine the CBR value for our subgrade. And from the problem, we are given several CBR values that we have obtained through the test carried along the proposed highway. So what we have to do now is to obtain CBR value for our subgrade. Okay. So to get our subgrade CBR value, we have to create a table of this one. So on this table, the first column is to have our CBR value, which was given based on the portions that test was carried out. So what this simply means is that a CBR value of 6% was gotten for 4 locations along the highway. So let's say this is the proposed highway. Along this highway, at this point, a CBR test was carried out. We had what? 6%. At this point, the CBR value was carried out. CBR test, we had 6%. Along this highway, 4 points gave us CBR value of what? 6%. Along this same highway, we carried out a test and we had what? 8%. 8%. And we had what? 8%. That's the meaning of number of locations. So we had 6% CBR value at 4 locations along the proposed highway. We had CBR value of 8% at what? 3 locations, and so on and so forth. So the first column will be our CBR value, and the next column will be our number of locations. So we want to determine the value of our CBR that we'll be using for our subgrade based on. So back to this table, what's the first thing we do? Okay, so on this table, the first thing we do, remember we are trying to determine the CBR value for our subgrade. We have our CBR value for our base and sub-base cost. So we simply sum up the values of the number of locations. So 4 plus 3 plus 3 plus 3 plus 2 plus 3 plus 2. That will give us what? 20. So if we sum all these values, we have it to be what? 20. Okay. So on our next one, we have values greater than or equal to. Okay. So on the first row, for the first CBR value, we have to write the summation of the number of locations. So we have 20 at this point. So how do we get our values greater than or equal to for the second row? It's simply 20 minus the number of locations for the first CBR value. So 20 minus 4. Now we equal to what? 16. So for the next row, it will be 16 minus 3. That will be equal to what? 13. For the next row, it will be what? 13 minus 3.
Yeah. 10.
And that will be 10. For the next row, it is 10 minus 3. And that will be 7. For the next row, it will be what? 7 minus 2. And that will be 5. For the next row, it will be 5 minus 3. And that will be 2. That will be equal to 2. And then we are done for this column. The next column we have to get is our percentage. How do we get our percentage? It's simply the various values for greater than and equal to, which is the third column, divided by the summation of the number of locations. So at this first point, we have what? 20 divided by 20 times 100. And that's going to give us what? 100%. So we have what? 100. For the second row, we have 16 divided by 20, which is the summation of the number of locations, times 100. And that will give us what? 80. This will give us 80%. So for the next row, we have 13 divided by 20 times 100. And that will give us what? 65. For the next row, using the same concept, compute for the remaining rows. Okay. So after computing for our percentage, we are done with this table. So to determine our CBR value for the subgrade, we'll be plotting a graph of our percentage against our CBR values. So percentage on the vertical axis and our CBR on the horizontal axis. So we have a graph such as this. So we have 6. So we'll be starting with our first CBR value. So our first CBR value is what? 6. So at this point it will be what? 6. So we have 8. Let's say we have 6, 7, 8, 9, 10, 11, 12, 13, and 14. So on the vertical axis, we are going to be having what? 10%. We have 10, 20, 30, 40, 50. Okay, so on the vertical axis, we'll be having 10 to 100 in percentage. Okay. So we'll be plotting our CBR value on the horizontal and our percentage on the vertical. So at the CBR value of 6, our percentage is what? 100. So at 6, our percentage is what? 100. At the CBR value of 8, our percentage is what? 80%. So at 8, okay. At the CBR value of 9, our percentage is what? 65. So at a CBR value of 10, we have our percentage should be what? 50. Okay? At the CBR value of 11, we have a percentage of 35. So we use a curve, we join these points. Okay. Now remember, what is our CBR value for our subgrade? It's simply the 90th percentile value from this graph. So on this graph, where is our 90? So we have our 90% at this point. So we draw a horizontal line from this 90th% to where it touches this curve. Okay, draw a horizontal line from 90% to where it gets to this curve, where it meets this curve. Getting to that point, we simply draw a vertical line downwards. Where this line cuts the CBR line is our CBR value, which is what? The 90th percentile CBR value that will be used for our subgrade. Okay, so from our calculations, we have our natural subgrade CBR to be equal to what? 7.1%, which is approximately 7%. Remember, we have to design the pavement. So what's the next thing we have to do after we have gotten our CBR values for different pavements? So these are subgrade CBR value. Okay, so our subgrade CBR value is equal to 7%. So the next thing to get is our average daily traffic. So from the question, we are given that the average daily traffic for one lane is what? 4,000. And then we have 4 lanes. So our average daily traffic is simply what? 4,000 times 4. Okay? So 4,000 times 4, that's 16,000. So that is our average daily traffic. Now, in designing our flexible pavement, we do not consider all the traffic. What we consider is the traffic that is causing failure. And from the problem, we are given that percentage of vehicles exceeding 3 tons weight is what? 8%. So it is the vehicles that are exceeding 3 tons weight that are causing failure to the pavement using the Nigerian CBR method. So of this traffic that we have, 8% of it are vehicles that are exceeding 3 tons. And they are the ones causing what? Failure to the pavement. So number of heavy vehicles, as we can call it, so vehicles that are causing failure. So we can say number of vehicles causing failure is simply equal to what? 8% of 16,000, which is 8 divided by 100 times 16,000. Now give us what?
1 to 8.
1 to 1 to
80.
1 to 8 0. Okay. Now we have known the number of vehicles causing failure, but we know that in reality, this percent is not constant. And in design, there is need for us to factor this value. So based on the given parameters of the equation, we are going to factor the value of the number of vehicles causing failure. So we head over to our table. So using table 2.2, so we can see initial traffic adjustment factor. So we are adjusting the traffic for safety. So if peradventure 8% of this vehicle is exceeded, there will be no what? Failure. Okay. So on table 2.2, Given a design period of 20 years and a growth rate of what? 6%. So we have our adjustment factor AF to be equal to 1.84. Therefore, our number of vehicles causing failure being factored is going to be equal to what? 1.84 times 1,280. And that's going to be equal to what? 2,355. Before we go ahead to design our pavement, points. That's it. Point 2. Point 2. So before we go ahead to design our pavement using this value, we also have to confirm based on the given design lanes, what is the percentage of this vehicle that should be used. So we look at table 2.1. So heading to table 2.1, which is lane distribution factors on multi-lane. Remember the question says our number of lanes is what? 4. So we are designing for the most critical lane, which is lane 1. So for a 4 lane, what is the percentage of the factor that should be used? It is 100%. Okay, so we are to use 100% of this value. So 100% of this value, which is 100 divided by 100 times 2355. That's going to be equal to what? 2355. We should note, if the given lane was not 4, we'll be using the lane distribution factor. So after getting the number of vehicles causing failure, after the factoring, we have it to be 2355. Next thing we have to get is to produce a tabular format like this, where we have the fresh coding to be our material/layer. We have our subgrade, subbase, base, and surface cost. So we have our design CBR. For our subgrade, we have the CBR as calculated to be 7%. For our subbase, we have a CBR of 30%, and for our base cost, we have a CBR value of what? 80%. So we have to complete the thickness above layer, thickness of layer, and then finally to get our adjusted layer thickness. And this will be in what? Centimeters. So to do this, using our number of vehicles causing failure.
Okay, so this is figure 2.2. Alright, so remember, we want to get thickness above layer from this figure, right? So the first thing we want to do, so we want to come, right? So we come over to this portion, right? So if you take a look at this portion, okay. So if you take a look at that portion, right? Okay, so if we look at this particular portion here, you can see that we have traffic classification. On this first column, we have what's called. In the second column, we have number of vehicles per day exceeding 3 tons loaded weight. So the value we calculated, which is value of vehicles that are causing failure, is the number of vehicles per day exceeding what? 3 tons loaded weight. So our first task will be to check on this particular segment, right? To check on this segment, right? Which category does our value fall into? So we have curve A 0 to 15, curve B 16 to 48, curve C 48 to 150, and so on. So we have curve F, which is 1,500 to 4,000 and above. Alright, so our value calculated was what? 2,355.2, which falls between 1,500 and 4,000 above. Alright, so we have gotten a hence, because our value falls within this, alright, at this point, we are going to use what? Curve F. Okay, so we'll be using curve F. Alright, so if we take a preview, right, over this, now we come to this other section, right? So as you can see on this part, we have what? California bearing ratio, right, in percentage. So we are going to be using the different California bearing ratio. Now let's also come to this part. All right. So at this point we have what? Curve A. This is what? Curve B. This is curve C. This is curve D. This is curve E. And then this last curve is what? Curve F. And this is the curve we are going to be what? Using. Okay. So we are going to be using curve F. So our first the thing we are going to do, so for a different layer, so we have calculated, we have our CBR value for our sub base. All right, we have our CBR value for our subgrade, and then we have for our base cost. So let's start from our subgrade, which we calculated to be 7.1. So we take that to be 7. So we come over to this axis. All right, so on this axis, all right, so we come to 7. So we have 7 at this point. So this is 7. So what do? We simply trace from 7. Okay, my line might not be straight, so we trace from 7 to what? Curve F. So let me do that again. So we simply trace, okay, so we have the 7 to what? Line F, to curve F. So where this meets at curve F, right? So where that line meets at curve F, that's the 7 line, we simply do what? We simply trace it above. So we have, this is 7. So we have 7 somewhere here to line F, right? So at this point where it meets the curve, we simply draw a vertical line what? Upwards. All right. Now, if we do this carefully, we have that to be 39, right? So let's take note of that. For our subgrade, which we have a CBR of 7%, we have it to be 39. So the next CBR value we have is the CBR value of our sub base. All right. So for our sub base, still using the same concept, all right. So we come over, so we have what? 30 at this point. So using the same concept, all right, for a CBR value of 30, which is for our sub base, we mark from that 30 points to what? Curve F, right? It's the same concept. So we mark to what? Point F. Remember, we are using curve F because our calculated value of number of vehicles exceeding 3 tons weight is higher than what? 1,500. That's the reason we are using curve F. So if we trace that, right? So if we trace that to that point, okay, so let's trace that again. So we trace it from 30, right, to curve F, and then at this point we simply draw it a vertical line upwards. All right. So if we look at this upper portion, right, let me mention that. So if we look at this upper portion, all right, so what can we see here? We can see pavement is centimeters, which is what? The different thickness above layer. So if we trace that upwards, all right, okay, so if we trace that upwards, so we trace from 30 to curve F, and then we trace a vertical line upwards, that will give us the thickness above layer for what? For our sub base. And then we have that to be what? 16.5. So let's quickly do for the last layer. So for the last layer, we have our base cost, and we have a CBR value of what? 80%. So still using the same concept, so we have 80 at this point. All right. Okay. So we have 80. So this is okay. So we have, this is our 80, as you can see. So we have 80 at this point. All right. So we simply move a horizontal line from 80 to our curve F. So this is our curve F. We move a vertical line upward. So it should be straight. This drawing is not that accurate. Okay, so if we do that very well, we have it to be 8.5. All right. So we have been able to get our thickness above layer for the different layers using the respective CBR rule.
Now, our next task is to determine our thickness of layer. Is to determine the thickness of our sub-base cost and surface. Now, note, our sub-grade layer is infinite in vertical direction and infinite in horizontal direction. We are to determine the thickness of our sub-base layer, base layer and surface. We cannot determine the thickness of our sub-grade layer. Why? our subgrade is infinite in vertical and horizontal directions. What do I mean? The depth of our natural earth is so much compared to the depth or the thickness of our base course, subbase, and our surface course. And in the horizontal axis, it is so large, wide, that we can see. But for our subbase, base course, and surface course, it is finite in the vertical direction, but infinite in the horizontal direction. Okay, so we cannot get thickness for our subgrade. So the first thickness we have to determine is the thickness of our subbase layer. How do we get that? It's simply the thickness above layer for our subgrade, which is our natural earth, minus the thickness above layer of our subbase. So 39 minus 16.5, we have the thickness of our what? Subbase layer. So 39 minus 16.5 will give us what? 22.5. Remember these values that we got from the figure are in centimeters. So we have this to be in what? Centimeters. So how do we get our thickness, the thickness of our base course? It's simply what? 16.5 minus 8.5. And that's going to give us 8.0. Okay? How do we get the thickness of our surface course? It's simply 8.5 minus 0. So the thickness of our surface course is what? It's simply 8.5 minus 0. So that's 8.5 centimeters. Now, these are the various thickness of our layers. But we want them to be in standard proportion. Okay? So we don't want them to be in decimals, we want it to be in a standard proportion. So what do? We sum the thickness of our layers. So 22.5 plus 8.0 plus 8.5 will give us what?
16.5.
So 22.5 plus 8.0 plus 8.5 will give us what?
36.
Will give us 39 centimeters. So now we have our total thickness to be what? 39 centimeters. What do? We proportion this value in such a way to the different layers that it will be at a standard proportion. So for our surface course, we have 8.5. We can simply vary it to be what? 10 centimeters. For our base course, we have 8.0. We can simply make it what? 10 centimeters, which is a standard depth. 39 minus 10 minus 10 is simply what? 19. So our adjusted layer thickness for the various layers is what? 10, 19 centimeters, which is also amounting to the total thickness to be what? 39 millimeters. So the next thing we can do is to draw a sketch of how this pavement will be. Now, after getting our different adjusted thickness, so we make the adjustment for standard pavement thickness layers. That was why we adjusted this value. Okay? So we simply get the sketch. Okay? So we have our surface course to be equal to what? 10 centimeters. We have our base course to be equal to what? 10 centimeters. And then we also have our subbase to be equal to 19 centimeters. If you want, you can convert these values to millimeters. And then we have our natural subgrade, which is infinite in the vertical direction and also infinite in the horizontal direction. Okay, so that is how to get designing your flexible pavement using the Nigerian CBR method.